chi-square test and correlation. So we welcome you once again, ma'am. Now over to you.
Yeah, thank you. So good evening all. Myself Dr. M. Radha from Tamil Nadu Agriculture University, Tamil Nadu. This is my mail ID radha@tnau.ac.in. You can contact me through this mail at any time. So today we are going to see the KW test, that means Kruskal-Wallis test and chi-square test and correlation. These are all the three topics we are going to see today. So before starting the core topic, we need to know the basic things. So where it starts. So generally statistics is divided into inferential statistics and sampling statistics. Uh, that means complete enumeration statistics. So this topic starts with inferential statistics. In this, we are going to know what is this inference, and within that we are going to see what is parameter estimation and what is hypothesis testing. Within that, we are going to see what are the types of errors available to make the decision, and what is alpha level. It is not A, it is what is alpha level means. Right? What is inferential statistics? It is nothing but using a small portion that is called a samples portion. We are giving the interpretation to the population. So the population is nothing but the area which is covered to take for our study is called as population. It is a big area. Within it is not possible to do all the things based on the total population all the times. It will take more time, more money, and more things. So we are always interested to do a sample study. So based on that, we are taking a small portion from the population that is called as sample. Using of that sample, we are going to give the interpretation for the population that is called as inference. Based on the sample values, we are giving interpretation to the population. So here there are two things available in this topic, that is statistic and parameter. So parameter, it is nothing but the characteristics of the population are called as parameter, and the characteristics of the sample is called as statistic. Not statistics, it is statistic. So in that parameter, we are having mu as population mean, sigma as population standard deviation, and pi as estimate of the population. And within that statistics, we are having x bar as sample mean, s as standard deviation, and p small p as sample proportion. These are all the things used under statistic and parameter. So based on the statistics values, we are giving interpretation to the parameters, that is inference. So for estimating the parameters, we are having two ways, that is point estimator and interval estimator. Based on the single point, we are giving interpretation means it is called as point estimation. Based on the interval, with an interval, we are giving the interpretation means it is under interval estimation. For example, we are giving a value, exact value as our estimation means it is x bar. If suppose based on the sample mean, we are giving interpretation, the population mean is exactly equal to 50. So here in sample mean is x bar is equal to 50. So within that, we may give the interpretation, the population mean mu may be 50. If we are giving interpretation like this means it is exact point estimation. In interval estimation, we are giving the results or inference based on the intervals. The mean may be lie between 40 to 60. So that interval is fixed based on the confidence level. Based on the alpha, we will fix the confidence level. If suppose we are fixing alpha level as 5% means our confidence level is 95%, which means that there is a possible of 95% possibility of mu lie between 40 and 60. This is the two types of estimation available under parameter estimation. There is a possible of error always. So based on the thing, the parameter is equal to always statistics plus or minus its error if it is in the interval estimation. And hypothesis testing, a statistical method that uses sample data to evaluate a hypothesis about a population parameter. And it is intended to help researcher differentiate between real and random patterns in the data. So based on the hypothesis, we may go with the statistical analysis. So what is hypothesis? It is an assumption about the parameter. So based on the parameter, we may have an assumption. For example, suppose there are there are 120 participants in the survey, means we may have previous assumptions or previous hypothesis. Based on that, we may have the BP of that participants, 120 participants may be 120. Means it is mu is equal to mean BP of that 120 participants is equal to mean BP of the participant is equal to 120. That means mu is equal to 120. So there are two types of hypothesis. Based on the assumption, we may have two types of hypothesis, that is null and alternative hypothesis. So the null hypothesis is always having the equal value. That means mean value mu is equal to some value. If it is not equal, means we may have it as an alternative hypothesis. There are two types of alternative hypothesis. We may simply have mu not equal to some value, or we may have mu less than some value, or mu greater than some value. So if it is simply not equal to, we are taking it as simply a not equal to value, means it is taken as simple alternative hypothesis. If it is not, we may take it as composite alternative hypothesis. So we are having two types of hypothesis, null and alternative hypothesis. In that alternative hypothesis, we are having two things, simple and composite hypothesis. So the results which we want to will be always in the alternative hypothesis. So that's why we are always trying to reject the null hypothesis, because the results, the researchers' interested result will be in the alternative hypothesis. So all the statistical test is to trying to test whether the null hypothesis is correct or wrong. That is the main motive of all the statistical analysis test. So alpha level of significance. So based on the confidence, how much we are having confidence, based on that confidence, we are fixing our alpha level. Suppose we are 95, we are taking it as a 95, means that balance 5%, 5% or 0.05, it is taken as alpha value. So the generally used statistical alpha is 0.01 and 0.05. Most probably we are using 0.05, which means that 95% confidence limit. Based on the confidence level, we are based on the alpha level, we are fixing our acceptance and rejection region. If suppose we are taking our alpha level as 5%, means that black dotted portions are our alpha areas. If we are taking it as a two, if the alpha is divided into two equal parts in the both the sides of this normal curve, it is a bell-shaped curve, means it is a two-sided test. We are having two types of test, that is two-sided test and one-sided test. If we are fixing our alpha level into any one of the side, means it is one-sided test. If we are taking alternative hypothesis, simply mu less than or equal to some value or greater than some value of dina, so which means that it is one-sided test. So mu will be only one side. That means alpha will be in the only one side. If suppose we are dividing alpha into two equal parts and putting it the two-sided, means it is called as two-sided test. In this bell-shaped curve is the example of two-sided test. Here it is 0.025. Both the dotted areas are 0.05 and 0.025 and 0.025. So the total 0.05 will be divided into two parts. The white portion in that bell-shaped curve is our acceptance region, that is critical region, or confidence region, that is called as acceptance region, acceptance region or confidence level. That black dotted portions are called as critical region or alpha. Based on the results, it is possible of two errors. Suppose we are fixing our null hypothesis. Generally, null hypothesis is denoted by the H0 and alternative hypothesis denoted by H1. Here it is H0 and H1. There are two things. H0 is a null hypothesis and H1 is alternative hypothesis. The error may occur based on the H0 because we are doing test to accept or reject the H0. So the error may occur based on the H0. Sometimes it is possible of rejecting the correct null hypothesis or accepting the wrong null hypothesis. These are the two possible things happen. Suppose accept H0 when it is false is called as type 2 error, and reject H0 when it is right is a type 1 error. Type 1 error is nothing but it is alpha value, and type 2 error is it is nothing but beta value. And that is 1 minus beta is always called as the power of the test. So there are two types of errors, type 1 error and type 2 error. Rejecting the correct null hypothesis is called as type 1 error, and accepting the wrong null hypothesis is called as type 2 error. And p value. So based on the probability value only, if we are doing manually means based on the calculated value and table value, we may give the interpretation, but we are doing it nowadays. We are using software to do all the statistical analysis. In that, we may have the p value that is called as probability value. Based on that probability value only, we are going to give the interpretation. If we are comparing the p value with our alpha value, if p value is greater than or equal to alpha value, means we do not reject H0. If p value is less than or equal to alpha value, means we may reject null hypothesis. And there are steps available to do hypothesis testing. That means all the tests. So under the hypothesis testing, we are having two types of tests. Generally, statistical inference is divided into two parts, that is parametric test and non-parametric test. The things we are seeing all up under the parametric test. So based on the parameter, we are doing test, means it is under parametric test. For using all the parametric test, we are having assumptions, which means that our data wants to follow a normal distribution. The normal distribution is nothing but it is under bell-shaped curve. The data wants to follow a bell-shaped curve or uniformity manner, which means that it is first assumption. There are all other assumptions available. The observations are independent and identically independent. Apart from that, we may have some other assumption. These are all the basic two assumptions. All the observations are independent, and our data wants to follow a normal distribution. These two assumptions are applicable for all the tests. Apart from that, based on the nature of the test, we are having some other assumptions. So first doing any parameter test means we need to test these two things. There are tests available to test these two things. If these two assumptions are okay, means we may go with the parametric test, or else we may go with the non-parametric test. The assumptions are violated, means we may go with the non-parametric test. So this is the thing about parametric and non-parametrics, where we want to choose parametric test and whenever we want to choose non-parametric test. If the assumptions are violated, the basic two assumptions are violated, means we may go with the non-parametric test, or else we may go with the parametric test. So under inference, we are having these two tests. So for all the tests, there are steps available. It is a 5-step process. First, we need to decide our null and alternative hypothesis. That is the first assumption. For example, if suppose we are taking a sample from the field, agriculture field, means we may have some assumptions. It is a chance of getting this much yield this year. In that, we may have mu is equal to that much value and mu not equal to that much value, which means that we may take it as a more than that value, means we may go with mu greater than that value. That is the null and alternative hypothesis. The first step in testing of hypothesis is to decide our null and alternative hypothesis. So the next step is fixing the alpha level. It may be, generally it is 0.05. If suppose we are more confident about our results, means we may go with 0.01. Apart from that, 0.01, 0.05 means it is 95%. We are confident. 0.01 means we are 99% confident. There is a possible of 99%. If suppose more confident, means we may go if suppose we are less confidence mean, we may go 0.10, 0.20. In some other banking field and decision making fields, they are going with 0.10 and 0.20 confidence levels also, which means that they are confident, 80%, 90% confidence about their results. That is the meaning of 0.2 and 0.1. And then number of samples, how many number of samples we are taking. If more number of samples will give the better results. So we may go with the maximum number of samples. After that, we want to know the test statistics. That is the third step. Test statistics is nothing but the formula which is used to test our parameter based on the statistics value. That is called as test statistics. So after the test is using that formula, we want based on the formula, what we are getting is called as calculated value. So based on that, we may have our results. If we are comparing that for this much sample and this much alpha level, there is a specified values available. That specified values are called as table values. After getting the calculated value and table value, we want to compare that calculated and table value. And based on that, we may give the results. This is the procedure whenever we are going with manually. If suppose we are doing the software means, after these things, we are doing all the analysis in software means, we may get the p-value. We want to compare our p-value with our alpha value. So we have already seen if it is p greater than alpha, greater than or equal to alpha means rejecting the H naught. If p is less than alpha means, p greater than or equal to alpha means do not reject H naught. If p less than alpha means reject H naught. This is the procedure. In parametric test, we are having test called is the test, t-test, and chi-square test. Chi-square test, sometimes it is under parametric test, sometimes it is under non-parametric test. Based on the nature of the data, it is under two categories. Sometimes they are considered it as a parametric test, sometimes it is considered it as a non-parametric test. So t-test is nothing but comparing the mean value. We are using t and z test based on the sample numbers. It is differentiated. If the sample is more than 30 means it is under z test. If the sample is less than or equal to 30 means it is under t test. And chi-square test is used to compare the qualitative data. Whenever it is quantitative data, we are comparing. Quantitative means there are unit of measurements involved. We are comparing that things. If it is quality based data means we are using this chi-square test. And what is the importance of non-parametric test? In this, we are going to see what are non-parametric tests and types of non-parametric tests and some of the orthodox examples for our KW test, chi-square test, and all other things. Already I told that it is there are most common parametric tests we are having these. If it is single mean, single, if we are interested to using single, there are types of tests available based on the things. Based on the number of the variables, we are divided our test into univariate test, bivariate test, and multivariate test. T-test is used for univariate and bivariate. If suppose we are having only one variable or two variables, means we may go with T-test. If it is more than two variable means we may go with this ANOVA procedure, that is analysis of variance. These are all the things available under parametric test. If suppose there are assumptions violated, these criteria include satisfying the assumptions of outliers, linearity, normality, homoscedasticity, and more other assumptions. If some of the assumptions are violated means we cannot use that parametric test. In that situation, we cannot quit the research. So we may go with the non-parametric test. If the data do not fulfill the criteria to conduct the parametric test, we can opt for non-parametric test, which do not require those assumptions. Then in non-parametric test, we are having minimum assumptions or less assumptions or no assumption. Some other tests in non-parametric are having no more assumptions. So it is easily used test. That's why we are if it is assumptions violated in parametric test means we may go with, easily we can go with this non-parametric test. The tests which are available under the title parametric, in what are the tests we are having in parametric, equivalent tests are available under non-parametric also. Instead of t-test, we are having some other test. Instead of ANOVA, we are having some other test. Instead of correlation, we are having some other correlation. Instead of regression, we are having some other regression. So we may go with non-parametric also if the assumptions are violated. But compared with parametric tests, the non-parametric tests are generally lower in power. So there are types of tests available under non-parametric, that is equivalent to parametric test. Instead of t-test, we may go with Mann-Whitney U-test. Instead of within subject t-test, we may go with Wilcoxon signed rank t-test. Instead of one sample ANOVA, one-way ANOVA, we may go with Kruskal-Wallis one-way table. And for two-way ANOVA, we may go with Friedman's two-way analysis of variance. So if it is, these are all the equivalent tests. Instead of Pearson correlation, we may go with some other correlations called Spearman rank correlation. Instead of linear regression, we may go with some other non-linear test available. That is logit, probit, all other things are under non-linear regression test. So now our topic is started, that is Kruskal-Wallis H test. Based on the H value, we are giving interpretation. That's why it is called as Kruskal-Wallis H test. The test statistics here it is called as H. If we are using T test, it means that the test statistics is named as T. If it is F test, means it is F. So Kruskal-Wallis test is called as H test. That's why it is H. It's a non-parametric procedure that can be used instead of one-way ANOVA. Simply, it is completely randomized design. It is equivalent test for completely randomized design. And based on the sum of the ranks. So here it is total number of variables available. So if it is ANOVA means it is more than 2 variables. So multivariate test. Non-parametric Kruskal-Wallis test is also for multivariate thing. So we want to give the rank. All the non-parametric tests is based on the rank or some values, total values, rank values, or these things are taken as the test statistics values. So based on the rank, this test is considered. And we need to give the rank within samples. Suppose, for example, we are having three different variables, means 3 different sample, means we need to give individual rank for individual samples, and we need to take it as a total. From first 1 to 1, we want to give the ranks and take total. That is tied observations are assigned, means some other it is possible as tied observation. If tied observation, there are procedures available to take the tied observation. Sometimes, suppose if there are only one observation in one rank, first rank, to one observation in second rank also, we are giving one first, second. Suppose there are 2 observations in the third rank, there are 2 observations in the same rank, means we may give 3 for all 2 variables, or else we may take average 3.5 and we may give 3.5, 3.5. Unless we may go with 3 and 4 for both the things. Next value also we may give. So there are types of ranking, tied observation ranking also available. Based on the nature, we may go with these 3 things, three types. So test statistics here used is H. It is the formula is called as test statistics. So H is equal to 12 divided by n into n plus 1 and summation of ti squared by ni minus 3 into n plus 1. N is nothing but number of samples, and t is how to calculate t value is the procedure here. It is given. If all n is equal to the ranks of all the n values is n1, n2, n3, nk, measurements are jointly ranked. All the observations are jointly ranked and it is taken as total n. And we use the sums of the ranks of the K samples to compare the distributions. All the sum of the ranks of the observations are taken at as t value, and here the t value is used in the formula. This is the formula to use to calculate the h value. And here it is null and alternative hypothesis, common null and alternative hypothesis for Kruskal-Wallis test. In null hypothesis, we are taking it as a k distributions are identical versus, and at least one distribution is different. That means that if there are three different, for example, three different samples are available, means all the samples are having same rank or same value. In that, we may have it as a null hypothesis. In alternative hypothesis, any one may be vary. That is our alternative hypothesis. And test statistics, we already seen that H value is test statistics value. Then, based on the things, when H naught is true, the test statistics H has an approximate chi-square distribution with degrees of freedom k minus 1. And how to do Kruskal-Wallis one-way ANOVA using SPSS. So in that, a researcher is interested in finding out if there is a difference in physical well-being, and the physical well-being is rated from 1 to 100 among teenagers, young adults, and seniors. These are all the three groups. Teenagers as one group, young adults as one group, and seniors as one group. The teenagers are between some age 8 to 17, and 18 to 35 are taken as young adults, and after that age is taken as senior. We recruited 10 teenagers, 10 adults, and 10 seniors for the experiment. In this case, the IV is age group and DV is physical well-being. So in that, this is the procedure to, so I will show you how to do the test by using our SPSS. Finally, once we will finish all the PPTs, means I will do all the things in SPSS. This is the procedure. In analysis, there is an option called non-parametric test. Under non-parametric test, we are having legacy dialog. In that, we may go with K independent samples. After clicking this K independent sample, we may have this dialog box. In this dialog box, there are two things available. First column is for physical well-being, and second column it is age group. Based on the age group, we are divided into three things. So based on the age group, we are make it as a first group, second group, third group. So the second column is for grouping variable. So choose first column as test variable and choose the second column as grouping variable. In that grouping variable, we want to give the group names. If we are giving 1, 2, 3 means we may take it as a 1, 2, 3. In that box, we want to click this Kruskal-Wallis H, and we may go. After clicking this, go to options and select descriptors. If we want to, we want descriptive values, mean, standard deviation, all the value means, we may click descriptive values, or simply we may click OK means we will get the results. So for group ranging, we may take minimum 1 and maximum 3 as group values. After clicking the OK means we will get the results like this. So the total number of observation and mean values. For teenagers, mean values are 21.70. In adult group, it is second group, it is 12.65, and senior group, it is 12.15. All the groups are having 10 observations. So N is denoted by the observation numbers. After that, we may have this box. It is a test statistics result. The Kruskal-Wallis H value is 7.501, and degrees of freedom, there are 3 groups. So 3 minus 1, it is 2. So degrees of freedom is 2, and this asymptotic significance is called as P value. We want to compare this 0.024 value. This is P value. We want to compare this P value with 0.05. That means with our alpha value, if this value is less than or equal to 0.05 means it is null hypothesis rejected. In null hypothesis, we are having all the three groups are having same value, same results. In alternative, we may have it as any one group name may vary. So if null hypothesis rejected means we may take one group is having different result. That is our interpretation. Although we know that there is a significant difference between the three groups, we do not know exactly where the difference lies. So it could lie between teenagers and adults, adults and seniors, teenagers and seniors, or even all of the above. So for knowing this thing, we may have median value or mean value. Based on the mean value, we may know that which group is different from the other two groups. So to test these things, we may go with a post hoc series of Mann-Whitney U test. Mann-Whitney U test may know the results, which group is giving better results than other two groups. So based on that Mann-Whitney U test, we may know these things. Next is chi-square test. Chi-square test is test used to compare the qualitative variables. I already told that. Excuse me. It is the test used to compare the qualitative variables. Sometimes the qualitative, simply we may have qualitative variables in a single manner means, hello?
Hello, ma'am. Hello.
Yeah,
Sorry for interrupting. Actually, I have
yeah,
doubt.
yeah.
Tested that Kruskal-Wallis test. Suppose we have
Sorry, your voice is disturbing. Some other noise is overtaking your voice.
actually, ma'am, we have a number of sample size, and I know already one way ANOVA we are using for that Kruskal-Wallis test, but
Mm.
to see the example, how we can we think like in that particular example, we want to use the Kruskal-Wallis test.
That I already told you, na. Based on the assumption, if the assumptions are violated, means instead of ANOVA, we may go with the Kruskal-Wallis test. Based on the samples we are having, we may know that whether it is applicable. If it is, how, in which place we can use one-way ANOVA, in which place we can use two-way ANOVA. If it is under one-way ANOVA, means instead of that, we may go with Kruskal-Wallis test.
Okay. First we have to see this is the one-way ANOVA and the two-way
Two-way ANOVA. Based on the nature of the data, we want to know. It is only simply we are comparing 3 or 4 variables, which means that we may go with one-way ANOVA. Instead of that, we are comparing two things. For example, if suppose we are having 3 groups, instead of this three groups, we are having some other thing to compare. We need to know the group, within group, is there any difference? Apart from that, we are having, suppose another variable as teaching methods. Instead of 3 groups, 3 age groups, 3 different age groups, and 3 different teaching methods. We want to compare these two things, which means that is there any difference within that age groups, and is there any difference within that teaching methods? Means we may go with two-way ANOVA. Instead of two-way ANOVA, we are having Friedman two-way ANOVA test in non-parametric test. These are all the manner to decide whether it is under one-way or two-way or T-test or F-test, like that.
Yeah, okay, ma'am. Clear, ma'am.
Okay.
Thank you, ma'am.
Yeah, thank you. So next, it is chi-square test. It is all, sometimes it is taken as a parametric test. Sometimes it is a non-parametric test. In my opinion, it is non-parametric test. So it is a non-parametric test that is used to measure the association between two categorical variables, two qualitative variables. Is there any association between? If it is simply a qualitative variables and it is parametric test, means based on the mean value we are comparing, If it is qualitative test, we are comparing the association between the variables, categorical variables. So we use it when we have observed frequencies of a categorical variables, like male versus female, healthy versus sick. Sometimes in sample survey, we are having a question like yes or no. In that types, we may go with chi-square test. Sometimes we may have a category based on farming size, small, marginal, and large. Means we may that based on the farming size also, we may have this chi-square test. There are two types of chi-square test available. That is chi-square test for goodness of fit and chi-square test for independence. Chi-square test for goodness of fit is used to compare the observed frequencies in a data sample with the frequencies based on some prior expectation. Simply, it is a difference between actual frequency and observed frequency, expected frequency and observed frequency. That is, expected values are decided based on the prior expectations, and actual values are our observed values. And next it is chi-square test for independencies, access whether observed frequencies are dependent or independent. That is another type of chi-square test. So generally this chi-square test of independence access is based on the table. That table is called as contingency table. So contingency tables are combination of two categorical variables. For example, if suppose we are having in our sample data types of farmers, based on that, adopting the new technology. Based on the size of the farming, we are dividing our types of farmers into small, marginal, large. So under types of farmers, we are having these three things. And whether you are adopting the new technology or not, simply it is a yes or no. So if we are combining these two things in a table manner, means it is called as contingency table. So in the chi-square test for independency is based on the table called contingency table. So it is an example of chi-square independency table. The previous example is for chi-square test for goodness of it. If suppose we are having frequency like this, means it is actual frequency or observed frequency. So we may have some other expected frequency based on our previous values, and that we are comparing that actual and expected frequency. Means it is under chi-square test for goodness of fit. In that we may have here in this we are having example frequency of visit by bird species at a bird feeder during a 24-hour period. So based on this example, we may have a null hypothesis. The bird species visit the feeder in the same proportion as the average over the past 5 years. Or this is not the same proportion average over the 5 years. It is null and alternative hypothesis. This is the example of contingency table. In this, we are combining two things. That is contingency table of the handlers of sample of Americans and Canadians. That is based on that we are having two handlers, that is right-handed and left-handed. In that we may take null hypothesis as the proportion of people who are left-handed is the same for Americans and Canadians, and the proportion of people who are left-handed differs between these two nationalities. Is null and alternative hypothesis. If this table is a contingency table, simply it is called as 2 into 2 contingency table. The number 2, first 2 is denoted as number of rows, and second 2, another 2, next 2 into 2, it is number of rows is 2, number of columns is 2. And if it is 2 into 3 or 3 into 3 or 3 into 4, any number, simply it is m into n contingency table. M may be from 1 to any number, 2 to any number, n may be 2 to any number, 2 to n. These are all the basic assumptions of the chi-square. Since we only require that the two variables are categorical, that is the only assumptions. There are no other assumptions required on the variables in the chi-square test. So this is the formula or test statistics used to test the chi-square value. Simply it is chi-squared is equal to summation of observed value minus expected value the whole square divided by expected value. That is summation of O minus E the whole squared by E. And summation is a summation of all the values. O is the observed and E is the expected frequency. And procedure to do the chi-square test in SPSS. Here it is the procedure. In that we need at least two categorical variables. If we are combining this two categorical variables using crosstab means we may go with analysis. Within that analysis, we are having option like descriptive statistics. Within that, we may go with crosstabs. In that crosstabs, we want to choose in row what are the things we want and in column what are the things we want. If we are after choosing this, we want to go with this statistics. In that statistics, there is an option called chi-squared. You want to click this chi-squared and click continue and then go with OK. And we may have the results like this based on the chi-square test. We are having the results. In that we may have number of valid cells and the chi-squared value, degrees of freedom, and this is p-value. Based on this p-value, we may give the results. And this is the cross tabulation table for that two. If suppose there is no expected frequency selected means we may have expected frequency values here. It is observed. Based on this value, expected frequency will be calculated. And we may have the observed and expected frequency values for all other three things. Fundamentalist, moderate, and liberal. These three things based on the three values. This is the procedure for chi-square test. And next it is correlation. So correlation is the, so apart from that comparing mean values, we are having another things called, we know the relationships of the variables. What is the, if suppose we are changing a value in one variable means it is possible to change or change the value in another variable or not. That will be calculated using of this correlation. So apart from mean difference, it is another thing, relationships. To finding of that relationship, we are having the things called correlation and regression. So now we are going to see only one thing, that is correlation. So it is simply know, it is used to simply know is there any relationship between the variables. It is two or more than two variables. If it is two variables, it is called as simple correlation. And if it is more than two variables, we call it as a multiple correlation. This is the things about correlation. Whenever we conduct any experiment, we gather information on more related variables. When there are two related variables, the joint distribution is known as bivariate and normal distribution. And if there are more than two variables, their joint distribution is known as the simple correlation and multiple correlation. That is the thing. To measuring the relationship, we are having this correlation. The correlation values are generally lies between -1 to +1. If it is 0 to -1, we take it as a negative correlation, which means that if we are changing one variable means the reverse thing will happen. If it is we are increasing the one variable means the other variable value may decrease. For example, price and demand, those are all negative examples of negative correlations. And the correlation values are lies between 0 to 1 means it is called as positive correlation. Example is fertilizer application and yield may be the perfect example for positive correlation. Number of pests and yield may be the perfect example for negative correlation. So the number of pests less means the yield may be higher. If fertilizer is higher means the yield may higher. And to know the relationship, we are having in two ways we may get the relationship between two variables or more than two variables. The one method is called scatter diagram. Based on this scatter diagram, we simply know the direction of the relationship only, whether it is positive, negative, or no correlation or any other. If apart from positive linear correlation, we are having another correlation called non-linear correlation also. In this thing, we are going to see only linear correlation. In linear correlation, we are having two positive and negative correlation. If it is based on the scatter diagram, we may know the direction of the relationship, whether it is positive or negative. If the data distribution is in this way, means either towards zero or from zero to this manner, means it is positive correlation. If it is opposite to this zero, means it is negative correlation. It is not possible to find out any direction, means it is zero correlation. It is some other, apart from linear line, it is some other diagram, means it is a non-linear correlation. Apart from that scatter diagram, we are having a formula method. That is, here it is the formula. Correlation is simply denoted by the letter R. Rxy means the relationship between x and y. So this is the formula: n into summation xy minus summation x into summation x divided by square root of n into summation x squared minus summation x the whole squared into n into summation y squared minus summation y the whole squared. After getting the correlation, we are testing the correlation because it is a sample correlation. Based on the sample values, we are having a correlation is R. Small r is denoted as sample correlation. We are testing whether the correlation is significant for population or not using the t-test. This is the formula to test the significancy of the correlation. That is t is equal to modulus of correlation value divided by square root of 1 minus r square divided by n minus 2. These are all the procedures, and there are assumptions and properties available for correlation. And these are all the assumptions. Correlation coefficient R is used to under certain assumption. They are the variables under study are continuous random variables and they are normally distributed. And the relationship between the variable is linear, and each pair of observation is unconnected with the other pair. This is the assumption taken as correlation, and properties are correlation value lies between -1 to +1. If it is minus values, it is negative correlation. If it is positive values, it is positive correlations. That are all the properties of correlations. And this is the procedure to do correlation in SPSS. Under analysis, we are having an option called correlation. Within that correlation, we may go with the bivariate correlation. In that, we are having we want to choose the two variables, which within that two variables only we are going to have correlation. So we may have two variables. If suppose we want to more variables, we may choose more variables. So in this variables and click OK. There are types of correlation available. Pearson is the linear correlation. So we may take this linear correlation, and Spearman-Kendall's are non-linear correlations. So in that we may have, and then go with OK. So we may have results like this. Within that results, we are having star options. Star options are testing a result, whether our results are significant or not significant. If suppose we are having only one star, means it is significant at 0.05% level. If suppose we are having two star, means it is both the levels 0.01 and 0.05, both the levels it is significant. There are two alpha values. So in this, we are having 0.335 as correlation value. It is positive value. So between the two variables, 33.5% relationship between the two variables, and the results are significant. This is the interpretation based on this correlation results. I will show you how to do correlation, all the things. So here I'm having sample data. So here I'm having only 5 values for each three groups, not 10 values. So the results may be vary from that PPT to this result. So there are three groups and physical well-being of three groups are denoted here. So I'm simply copying this data. This is the window of, is it visible?
Yeah,
This
yes,
is the
ma'am.
yeah, this is the window of SPSS. I simply copy this, copy and paste the values. Need not to copy these titles because we need to type the titles. That's not copy. We may have copy and paste options. It is not copy. It is a trial version. I simply type. So there are views available, data view and variable view. Here we want to specify our variable things. So first I will type the values. Wait, it is. If you are having any questions, you may ask because it is taking time.
Yeah, participant, if you have any query, you can interact with our esteemed speaker. Till time ma'am is running the software, so you may ask if you have any query.
Okay, I think it is taking time. If possible, I will show, or else you may. I will share the slide. Within that slide, there are procedures available to do all these three analysis by using of SPSS. So you may try in your side. I will share this PPT along with the data sheet. We are having any